Let's now say some words about limits and continuity. You may have seen this symbol in the real case, lim f of x as x approach x0. What does that mean? Well, if this limit exists, then we have the situation that when we are approaching x0 from below, we get some the function f of x is approaching some number, and if we are approaching x0 from above, this function f of x is approaching the same number. So in that case we say that the limit exists. In the complex case we have a little bit more complex situation, so to speak. In this case we have to approach the same number for any curve through the point set 0. And it's not only sufficient that these curves are straight line. These curves, it should be any type of curve. Here is some counterexample where the function approaches 0 through the origin through any straight line. But if we go along the curve r equal to theta, we are using here polar coordinates, then the function will approach 1. So that's not the same limit as for the limits through any straight lines which are 0. So this is an example where the function is the limit does not exist when x is approaching origin. Well, this may be a little bit difficult for you to understand, but let's consider an example, and then it will be much easier for you to understand the concept of limits. And usually, in order to understand the definition, we should take examples where we don't succeed in getting the definition fulfilled. As in this example, f of z is equal to z over z conjugate. If we are approaching z0, which in this case is assumed to be 0, from this line, from the horizontal line, which is described by set values which takes the value x plus 0i, then we see that along this line f of z is equal to x plus I0 over x minus I0. So this number will be equal to 1 at any point. And of course, the function f of z must then approach 1 when x is approaching 0. Well, so along this line we get one limit, and the limit is 1. The same happens if we go along this horizontal line from below, of course. If we are going through the point set 0 equal to 0 from above, from along this imaginary line, then the following happens. Then z is equal to, has the x value 0, but the imaginary value is now an arbitrary value y. And in this case f of z is equal to this guy over this guy, which is not 1 but minus 1. So this means that when we are approaching 0 along this vertical line from above or below, then f of z is approaching -1, not 1 as we did along the horizontal lines. So these two limits are not the same, and we conclude that the limit f of z as z goes to origin z0 equal to 0 does not exist.